好，开始。
大家好，老师好，我叫李光安，老师是林贝勒老师。因为我的中文不太好，我用英文讲。谢谢。This is my outline, and my topic is impact of the low-level jet on the overheat island intensity in Oklahoma City. And this is the reference. And this is my outline. The first part is the keyword introduction, data model, description, method, result, and conclusion and discussion. This is a keyword. There are two keywords here. First keyword is about the natural low-level jet, and it is a stream of fast-moving air with wind speed maximum in the low wind 2 kilometers. It is one of the prominent features of the natural boundary layer in the Great Plains of North America. The second keyword is this urban heat island. It's a phenomenon of urban weather modifications in the so-called urban heat island effect, in which near the surface temperature in the metropolitan areas are typically higher than surrounding rural areas. And this is my introduction. Most of the UHI study concludes that USI signal is strongest at night, and interaction between the UHI phenomena and other features of the natural boundary layer source are thus particular interest. As there are more studies focused on climatological description of low-level jets and the roles of topography in low-level jets, and to improve the analytical description of low-level jets. Why the urban study highlights that urban effect influenced by low-level jet dynamics is remain unclear. What effect low-level jet dynamics affect the UHI development and intensity? Since the UHIs and low-level jets are both frequently observed in Oklahoma City metropolitan area, it is ideal location to further study the interaction between those natural phenomena. And this is the data. This data is in the campaign experiment happened in 2003. This on June 2003. This happened from July and late June to late July 2003. The area is Oklahoma metropolitan area here, and this figure is a land use data of this area. The purpose of this campaign is the focus on proving data sets for the improvement of application of the urban dispersion model. And this I'm going to describe the main data. This is the two boundary layer data wind profile, which is observed in the PNL and the ANL. And there are the heat and movement flux. Tau is constructed in two layers, is a 37.3 and 79.6 meters, and two near surface temperature data set at 2 meters and 9 meters. In this study, we use the data from the ANL wind profile, which is moving from is converted from 82 to 2000 meters, and the mean rural temperatures at 2 and 8 meters is calculated using the temperature observation in 6 Oklahoma sites surrounding Oklahoma City here. And the metropolitan data collected by the Oklahoma Mesomet. And this map the three rural sites you can see. And this model description, they are using Word version 3.4, and they choose 4 times is called the 4 episodes. It's happened on 17, 18, 24, and 25 July. And the grid spacing is 40.5, 13.5 and 4.5, 1.5 and 0.5 millimeters with 48 vertical layers. And the scheme, all the details of the scheme are listed here. And it's special here is they use the ACM2 to simulate this case. Previous studies they all use the Johnson University scheme, but in this here the author choose the ACM2 for several reasons. And here's the method. The method that USI intensity determined 2 and 9 measure following those applied in 2008, and it's very simple. It's just delta T. Delta T is a temperature in urban minus temperatures in the rural area. Since the two measure urban observation is only recorded during this campaign, and the author had decided to primarily use the 8 measure for the USI signal for their analysis. This will allow us to expand the study over a long time period in the future. And here, these are the results. This is Moody's data to give us the typical images of the Oklahoma area and city. We focus this Oklahoma area and 6 rural areas around this point in the red. Is in the red point. This is nighttime and this is the daytime. The daytime you can see that we can the urban heat island effect is not clearly because also this is the mountain areas, and it's not very clear, but in the nighttime it's quite clear that Oklahoma and Dallas is having the temperature in the city core is much higher than the surrounding area. And further study also indicate the low-level jazz modulate the UHI, but here with our data and the method, we can compare tools. Index is the low-level jazz strength and the UHI intensity. Here we see the inverse correlations. The inverse correlation with these two index. The so-called UHI intensity is the delta T, which I already mentioned. And what doesn't show here is the observation vertical wind profile, various location in the Oklahoma City metropolitan area, include the rural areas, suburban areas, and urban areas. The low-level jazz strength very little, just less than 0.5 meters per second. It's leading to the conclusion that the high correlation shown in this figure. The correlations, inverse correlation is a 0.81. Is suggests that this the variation of low-level jazz strength played an important role in the modulate the UHI intensity. And to further investigate this, we go into the 4-day Ponder episodes, and they divide into this 4-day into 2 strong episodes, and this is a weak episode. In the strong and even in the strong or weak episode, we can see that the daytime of the temperature in 2 and 8 measures is and here the UHI intensity is nearly 0. It means that, as I said, in the daytime the UHI intensity is not, it can be neglected. And but in the nighttime it's quite high. For the strong episode is higher than 2 degrees, and for the weak episode is is about 1 degree. So we have the sounding to see what's happened in the layer during that time. You can see here is a strong episode. The inversion layer is very low. It's only developed until more than 200 meters. But here for the weak case, it's nearly neutral boundary layer explained for the UHI intensity at both 2 and 8 meters a weak episode. And the previous study also showed that maybe the synoptic skin weather condition is affect the low-level jet stream, and we demonstrate it here. This is the red dot is Oklahoma City area, and we see that in the weak in the strong case is mean July 18 and July 17. The gradient in Oklahoma City area is not as high as in weak case. It indicates that the low-level jet stream in the weak case going to be stronger in compared with the strong case. And we double confirm it in the observation data and simulation data to see how good our simulation can catch this signal. And in the strong UHI signal, it means the low-level jet stream. You can see here the work model catching quite well. Of course, it's underestimate the low-level the wind speed, but they capture quite good the pattern of the observation data. And here we show the bias. And the bias is quite good at especially nighttime, and daytime is not as good, but our focus is on the nighttime. And in the weak episodes, it means the strong low-level jet stream is also simulated quite well. And when we to explain it, we go to the simulator so to see the whole figures of the simulate wind speed at 10 meters. And this strong case, the wind is the wind in. Please take attention in the dot area. The dot area is the experiment area. So, and the dot is indicate for the observation data. And here we can compare the simulation data and the observation data. It fits quite well, especially in the strong case. And when we go to the higher layer, it means close to the low-level jet stream layer is 500 meters, and we see that the typical directions of the strong K is south and westerly, and with the weak K is this K is south, this is northern, and in the weak K this is northward. So it is typically different, maybe because of different in topography in the weather system. The feature shown here see that low level dredge stream in this weak K is quite spread out in a very large area. And here is surface temperature simulations compared with the observation. For the strong case, of course, the temperature different. The temperature is higher in the hot spot here, like here, and it's not as strong in the weak case. And we previous study in this campaign also they indicate that the strong shear associated with the low level dredge stream can cause a strong turbulent mixing in the neutral boundary layer. So we see the friction velocity and the TKE was measured to verify this. And this is the strong case and this is the weak case. And we see that in the strong case, the friction velocity dropped down less than 0.2 meters per second. It means 30% of the daily value, and the TKE decreased to even the negligible level. But for the strong low-level dredge case, the friction's velocity and TKEs remain relevant at night. So it indicates that in those strong low-level dredge case, the radiative cooling is can be replaced by the mixing of TKEs, and friction effect can be replaced by the strong shear associated with the low-level dredge stream in the both layer generate a lot. And the inversion strength can is had strong relative with the low-level dredge stream. And here in the simulation data, we show the inversion strength by seeing the vertical gradients, vertical temperature gradients in this layer. And we see that this inversion strength and temperature signals also catching quite well with the USA intensity. It makes the author think that the inversion strength can be index to indicate the strength of the USI intensity. And here the PBL height is calculated to see and the warp simulation capture the observation duration nodes and the USI intensity contrast between strong and weak USI episode very well. And the similar simulation further highlights that directional variation in the PBL height moderates the directional variation of USI intensity. To compare the simulating spin temperature, we use the simulating temperature spin temperatures and the land surface temperature, which is generated by the MODIS data here. The top is the simulate data, and the down the bottom is the Moody's data, and we see that for all four cases it captured well, especially in the strong case. And the weak case is underestimated in this area, but maybe we don't have much data in this area, and so we cannot sure that is wrong or right of the simulation. Here it's just based on the Moody's data. We don't have the observation data of the campaign. And here, the simulation from the simulation, we can see that from the the potential temperature profile for the strong case, the inversion layers is about 200, and for the weak case is about 500. And also the wind speed of the low-level jets also agree with that. Is lower in the strong case and weaker in the weak case. The results here is the strain. They compare the inversion strain and the natural urban heat island intensity strength, and the correlation is quite well, and it implies that the temperature inversion in the surrounding rural area can be used as an indicator for the USI intensity. And the last part is the conclusion. Is from this paper, they show that day-to-day natural USI intensity in Oklahoma shows the great variability in the July of 2003. A significant correlation was found between the mean USI intensity and trend of the low-level jets. During this week USI episode, the east and west pressure gradient contribute to the accelerate of the northward blowing low-level jets over the Great Plains, and we explain for the weak signal of the USI signal. And the rural temperature inversion train near the surface is shown to be directly indicator of the natural USI intensity. And the inversion in an inversion study, the synoptic condition was also reported that includes USI intensity. But in this study, we could identify a kind of turbulent mixing strips and low-level jets as a mechanism which synoptic conditions alter the USI intensity. Because of the unrealistic and strong mixing model, underestimate the trend of the temperature inversion in the NBL, and as a result, the speed of predicted USI intensity was also poor in the Yonsei University power regulatory scheme, PL scheme, and so they select the ACM2. That is not shown in this, so the results in this study, but in other study, ACM2 scheme is also show this simulated natural low-level regime and the impact on the USI intensity better. In addition, this to affect the USI and low-level jets may also have an important implication for the transport and dispersion pollution. Thank you for listening.
同学发问，可以用你们的话讲。小金。
你好，我是硕一林小军。I want to know why the strong low-level jets is higher than the weak low-level jets. the height of the low level jet in strong case is higher than
It's stronger.
the
It's stronger.
strong low level jets.
It simulates or
The
Observation.
figure 11.
Observation. No.
Yeah.
Okay. Yeah.
On this one, on the bottom two figure. Yeah, the height of the low level jet.
Maximum wind speed. Height of maximum wind speed. Right?
Yeah.
like because of the boundary layer in this case can grow in deeper, so the maximum also can be higher than to compare with the weak case.
But the PBO height is a result of the lower we define the lower jet noise, the maximum speed, the height of the as
I think also because of the PBL height is higher, so you can compare maybe the low level jet height is higher, so this layer is thicker, so the center, the maximum area also can be higher than the low case.
What is the connection of PBO height and low level jet?
Like low.
Because you think PBO has a reason for, PBO has a reason for the enhance the low level jet in upper layer. But I don't know why you think there's a connection of PBO high and the low level jet. Can you go back to the potential temperature profiler? Okay, so did you notice where is the inversion layer? What about the other one?
The other one here we don't is nearly neutral, so
But you can still tell above the neutral layer is inversion layer.
yeah.
Is there a connection of this one in previous figure? This one. Did you notice typically the low level jet occurs in the top of the inversion layer, right?
Yes. So here the low level jet is happening above 200 meters, and
So
and the
it's
inversion layer here is about under 200 meters. Is achievable.
But I think you need to go back to think why the low level jet occurs in the top of the inversion layer.
Right here, the answer says that the low level jets in the synoptic scale also stronger, so it's help to mix the bottom layer go to higher. So maybe the mix because of the shear created by the low level jet can create it's like the egg chicken because of the low level jets can increase the height by the dynamic process.
I agree.
So if you say that like because of the inversion layer is high, and you say that so because of the reason in the inversion layer is high, it makes the low level jet higher. So I also can say that because low level jet is high, so it makes the inversion layer higher.
No, then I think I want to ask is why the low level jet is formed in this region. 就是你们了解刚刚的问题是什么吗？就一开始的问题，小编问题是说，就是两个 case， 一个是左边是 UHI 的 urban heat island 的比较明显嘛，那右边那张图是 urban heat island 比较弱的情况之下，但在这两种不同情况下，它的 low level jet 的高度其实不太一样，左边的比较低一点，右边的比较高一点。那小编问题就是问说，为什么它会有高度上的不同的差异？那其实 low level jet 在晚上形成的话，它有很多原因，但是在这边的成因，其实因为他没有讲，所以我也不是很清楚。所以我刚刚想问的是说，为什么 low level jet 在这边会形成？但是我刚刚是因为他刚刚是想要从 P 边界的高度来解释，可是我觉得不太对，因为其实 low level jet 通常会发生在逆温层的顶部，那逆温的原因基本上。因为 low level jet 基本上你可以把它想成是一个 momentum 的一个 exchange 的过程，因为 momentum exchange 通常是你知道风速就是随高度递增嘛，那有一个梯度在，就会有一个通量传递，所以有个通量传递代表说风速会由高的地方往低的地方传，所以 momentum 传递是从高往低的地方传，对，因为风速在上层比较高，在下层比较低，所以就会有一个 mixing 的过程。但这个 mixing 的过程之后，它到逆温之后，因为那边逆温就比较稳定，所以基本上那边不太会有这个能量转换过程，所以造成在这个 inversion layer 的顶部，变说你 OK， 我可能我的 momentum flux 没有办法往下传，所以造成在逆温层底部产生一个加速的行为。OK， 所以才会变成说，通常在那个地方通常会有一个逆温层形成，但是就是这边有一些就是不是很清楚的地方，就是说 OK， 那我觉得 low level jet 到底在这个地方到底怎么形成的？这样子。所以我才会又回过头去再问他说，那 low level jet 到底是怎么形成
？Like from a simulation, because it's not an observation, but from a simulation, and here you see the windward side in the weak case, in the weak case is the southwestward, right? But in the strong case is northward and not eastward. So I think because I'm not sure, but the author here also only mentioned that the low level jet here cannot cause because of the interaction with the high mountain in this west area. So that could be. I'm not sure, but that could be. They say that the low level jet also is affected by the topography.
OK， 还有总力量可以吗？老板有帮你回答一些问题。OK， 然后一个外的 report， 其他有没有问题？
Can you show the temperature at night and the day? The former whole point.
This one.
Yeah, why the temperature at night is higher than at the daytime?
This is the night. This is nighttime. This is daytime.
Yeah. Why the temperature is
No, it's
higher?
not higher.
In Dali City,
This is the nighttime.
in the Dali City, this is the central city, right? And the temperature in night, no, the
Here.
the A figure,
A figure.
dollars here. The
Is Dallas also a big city? Is it even bigger than Oklahoma? But
is not city.
Yeah, that's a city.
My question is, why the temperature in nighttime is higher than daytime?
Oh.
那 scale 不一样吗？ Different scale.
Here is like about less than 300, and here is higher than 300.
Okay, different scale. Okay.谁在还没问题？好，方面。
There's something I don't quite understand, and your explanation is not clear. And like is there what is the interaction of urban heat island and the low-level jet? And also, what is the interaction of inversion layer and the low-level jet? Because inversion layer typically during the night, because we are reactive cooling, so inversion layer forms. But I think two different cases, probably some of the synaptic scale or topographical, something causing the module changes of the low-level jet for both cases. And one is with strong and one is with weaker one. And the weaker one will causing less mixing. So in other words, we can also say the urban heat island or the inversion layer is more apparent than the stronger mixing case. Stronger mixing, so we see more neutral conditions and more well-mixed condition. 就是我想回头再去解释说为什么比较低会比较，因为刚刚好像还是没有很清楚。那因为一个比较弱的 mixing， 就是比较强的那个 urban heat island， 但因为它的解释是 low level jet 比较风速比较小，所以它 mixing 比较弱，所以你可以看它逆温层还是非常的明显嘛。但是右边那个 case 就是热岛效应比较，差不多热岛效应比较弱，但那个 case 里面是 low level jet 比较强，它比较强的话，自然而然垂直的混合效应就会比较强。所以你看到的位温的梯度就会比较呈现中性的状况，所以自然而然看到整个逆温层都拉高了。所以那个部分我觉得是从 low level jet 的角度去解释，但是另外还有一个问题就是说，就是我觉得就是整个 urban heat island， 那因为这个原因，它又间接的造成low level jet 的垂直混合 mixing 影响，造成两个的那个 urban heat island 的那个 strength 不一样。所以它就变成说，它最后的总结是从这个 low level jet 去解释这个 urban heat island 啊，就是 UHI index。But so my question is the interaction of the low level jet and this inversion layer is not completely explained, and also the interaction of the low level jet and the urban heat island. I think that's the point of this study. The connection of low level jet and the urban heat island. These things is not clearly explained.
So you want me to explain the physical process, the interaction version, or I can explain it on the report.
Okay. One
question. About the definition, strengths of inversion layer. How do you define that?
Strength of inversion layer, they define that the gradient of the vertical temperature.
The gradient, how that changes high.
Yeah, it changes. From the at least here for the observations, they have the 2 meter and 9 meter, so they can have the gradient, and if you run the simulation result with work, you can have more detail about the gradient of this inversion layer. But for the observation, just you can use the 2 measures and 9 measures.
Can you like reason out what is the cause and what is the result? Like is low level jet causing urban heat island or urban heat island causing or the urban heat? Is there a connection of
Yeah.
the result of the urban heat island between two cases? Are they really induced by low-level jet? Because the definition of urban heat island in your case is the temperature difference between rural and urban.
So here they say that here they say that the low level jets affect the urban heat island because when the observations in the vertical wind profile location around the metropolitan city, that the low level jets doesn't change much. It's just very little. So it's because of that they say that not in this case the low level stress affect to the urban heat island than more than urban heat island if I change the low level jet. Because if the urban heat island, if I change the low level jet, so this verify from the rural and urban area of the whole this area or sub-rural area gonna be very high.
OK，谢谢啊，谢谢 ，Thank you。